Okay, so yesterday we looked at given some models, right? Looking at solving and so our balancing. We looked at the hangers. So can I determine the value of some of these shapes and what do they look like? So we're going to continue to look at models, but today what we're going to look at is how can I, if I give in a model, how can I turn it into an equation, right? So we looked at writing these equations like what do I know, what do I not know, right? We talked about variable, we've talked about coefficient. And so now, how do I go from a picture back to the model, from the model, excuse me, back to the equation? So that's what we're going to look at today. And then eventually we'll start again talking about how do we solve for these missing values, how do we solve for the variable. We looked at substitution, but again, today we're not solving, we're just looking at how can I make a model into an algebraic equation. So let's take a look. So here I have an example of a model equation. And again, how do we know this is an equation? Well, because of that guy right there, right? The equal sign tells me I have an equation. So basically what I want to do is take this picture and I want to rewrite it with numbers and variables and coefficients. So we're going to use this key here to help me do that. Now, because we know this is an equation, we're going to start with the equal sign. So I'm going to look at what do I see on either side, right? This is my left side, and this is the right side of the equal sign. So let's just look at the left side. So I see these rectangles, and I know I have 4 of these rectangles, and let me shade them blue. Okay. So I'm looking at these 4 rectangles here, and if I look at the key, the rectangles tell me that for each rectangle, it's worth 1x. So that's worth an x, that's worth an x, that's worth an x, that's worth an x. So I know my variable here is going to be the letter x. That's my unknown. Okay, so the coefficient, or the number that cooperates with the variable, is simply going to be the number of x's I see. So when I count the number of x's, or the number of rectangles, 1, 2, 3, 4, that's my coefficient. So what we're doing is literally writing what we see. Right? I see 4 rectangles. Each rectangle is worth an x based on the key. So therefore I have 4 x's. Okay, I'm going to look what else do I have on the left-hand side of my equal sign here. What else is in the box? I see some squares that are non-shaded. So I come over here and look at my key. And I see that non-shaded squares are worth 1 positive. So at this point, all I have to do is count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positives. So I can just write that as 12 positives. So right now my equation has 4x plus 12. Okay, that's one side, that's an expression. But since we have an equal sign, we also need to figure out what's on the right-hand side. So again, I'm going to come back to my key and I'm going to look. Okay, well, I have these shaded in squares. Okay, so what's a shaded in square worth? And what the key tells me is that for every shaded square I have, it's worth 1 negative. So again, I'm just going to count. Well, I have 1 negative, 2 negatives, 3 negatives, 4 negatives, 5 negatives, 6 negatives, 7, and 8 negatives. So then I'm just going to write what I see. So now I have my equation that is modeled, by this picture. I have 4 x's, 12 positives is equal to 8 negatives. And that's as far as we're going today. So let's look at another example of this. So again, we have a balanced scale, right? Because when we talked about equations and you looked at your activity yesterday, you wanted to keep it balanced with solving, right? That's the idea of equality, is it's balanced in mathematics. So again, we have a left side and a right side of an equation here, and I have an equal sign, so I know it's an equation. Again, I'm going to count what I see. So my variable here is x, and I want to count how many x's I have so I can figure out what my coefficient is. We're just going to count them off. 1, 2, 3, 4, 5 x's. So then let me see what else is on my left-hand side of the equal sign. So remember, this is left, this is right. So here I see circles. Okay, so the last one we had squares and a key. In this one, we have circles with a 1 in them. So we're going to go ahead and assume that these are positives, because what you're going to see in other types of models is you may see a circle with a plus in it for positive. You may see a circle with a minus in it for negative. You could see a circle with a -1 in it for negative. You could also see a box with a negative, a box with a positive, a box with a -1. Okay, it's going to be very clear on what we have. And in this case, because since we don't see any negative symbols inside the circles, okay, we're going to assume, and we are correct in the assumption, that these are positive ones. So I'm just going to count 1, 2, 3, 4, 5 positive ones, and I'm done with the left-hand side. So now I'm just going to look, what do I have on the right-hand side? Again, no negative signs present, so these are all positives. And I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positives. And so now I have my equation. 5 times some number, x, plus 5 is going to give me 15. Okay, so you probably can kind of figure that out by looking at it. But again, we're not solving today. I'm not asking you to tell me what the value of x is. I'm asking you, if I give you this picture, can you create this? All right, so let's look at one more example, and we're going to see what we might notice is a little different about this example. Okay, so again, we have some p's as a coefficient this time instead of x. So I wanted to show you this because remember, a variable doesn't necessarily always have to be x. So again, I'm going to start with my equation. Symbol. I have a left side and a right side. And I'm just going to write what I see. Well, I know I see the letter P, and I see 4 of them. I see 3 negatives, so on my left side I'm done. So on the right side, again, so we see how the negative symbols are in the circle, so we can see those. I also want to see how many negatives I have on the right side. So if I count them off, 9, 10, 11, 12 negatives. So again, I have the equation that represents that model. All right, so let's look at a last one that you guys would see on the 8th grade. So all of these ones we looked at are, we see one variable on one side of the equal sign, okay? So this is more on what lines of what you guys need to be looking at. And then what we notice is that this time I do have an equation still, because I still see my equal sign right there in the middle. But you notice this time we have x's on either side of the equal sign, okay? Our steps aren't still going to change, right? Because we're not really concerned about that today. Now tomorrow when we start solving these, that's going to make a big difference, right? And yesterday when we guys looked at models, that kind of made a difference about where are the x's and things like that, okay? Today we're not really concerned about it, because really what we're doing is, remember, what our goal is, what our question was, is can I take this picture here and turn it into an equation? Okay, so again, remember, we're going to split it in half. We have a left side and a right side. And I'm just going to simply write what I see on the left-hand side. So here I have my variable of an x. And I'm just going to simply, the coefficient is going to be how many x's do I see? And in this case, I see 4. Now I'm going to look at my boxes here. Now I notice here, in this case, I do have negative symbols in here. So I'm just going to ask myself, well, how many negatives are there? And when I count them, I see that there are 5 negatives. So my left side of my equation is going to be 4x minus 5 is balanced with what? Well, let's look at it. What do we see? Again, now I have 3 rectangles with the value of x in them. So I have x with 3 of them. Notice how they're the same shape. They're just on opposite sides of the equal sign, as well as 1 negative. So given this model, the corresponding equation is 4x minus 5 is equal to 3x minus 1. Again, not asking you to go back and look in solving this. The question was, given a model, can you write the corresponding equation? Okay, so what you're going to do today in your practice on Desmos is this very similar aspect. Okay, you're going to see another video that walks you through this one more time, and then you guys will answer some questions and then be able to see if you can match equations to models. All right, if you have any questions, let your teacher know, and then tomorrow we'll start solving. So hope you guys have a great day, and we'll see you guys soon. Thanks.